Guys, whatever I've explained, okay, previously, I'm showing the practicals. Okay. Okay, so this is the program. When I say young Jafar, okay, it's showing me all the word count actually. Okay, so do you have any program to? Okay, so we don't have that. Okay, so we'll go with the word count only. Okay, so now this is the program I'm giving guys. Okay, so I'm deleting. Okay, if the folder is already existing, I'm deleting it. Okay, so now what is the program I'm giving? First program. So before I start, okay, so let me open the resource manager UI also. So this is the resource manager UI. Okay, so we already have one. Okay, so leave it. Okay, we executed this on March 24. Okay, on Thursday. Okay. But now I'm executing the program. Okay, so okay, before executing this program, okay, let us understand okay, where is this file first of all. Okay, CFS TFS hyphen. Okay, so this is the command. Okay, we will see FTFS FSAK command. Okay, so this command will tell you where are your file blocks actually. Okay, so now if you see this file, okay, project sample1.txt. So this is having two blocks, BLK 1848, 1849. 1848 is in 185 machine. Okay, so this is the machine where we have 185 means this machine. So this is the place I have 1848 and I have 1849 also. Okay, 1849. Okay, these are the two blocks of what we have. And we don't have these data nodes, right? These are only three data nodes what we have. Okay. Okay, so these are the two data what we have. These are the two data nodes what we have. Now, okay, I'm Alan here. I'm Alan. Alan is the one. Okay, Alan is submitting a yanjar command. So he is coming here and okay, he is submitting the yanjar command. Okay, when he's submitting the yanjar command, what Alan is doing, Alan is passing the jar file first of all, okay, which is nothing but your logic file. Inside this jar file we have multiple classes, right? Okay, which class we want, he is passing word count class. Okay, so what is the input file? What is the input file? Sample1.txt. Okay, and sample1.txt has how many blocks? Sample.txt is having, okay, if you want to execute a program on sample1.txt, it has okay, two blocks. So this is the first block, which is of okay, and this is the second block. Okay, so first block is 250 MB. Sorry, 128 MB. Second block is 128 MB. Yes or no? Okay, and okay, both are available here. This is the place. Okay, block one is available. This is the place where block 2 is available. Okay. Are you clear till now? Are you clear till now, guys? Huh? Now he is submitting the jar command. Okay. And jar command center. When you submit jar command, immediately the request has been taken by your resource manager. See what it is saying. Connecting to resource manager. So at the same time, okay, let us see in the back end of the JPS. Okay. So do you have run jar started? Okay. This run jar will be there until your job is completed. Okay. So it is still there. It means okay, your program is still running. Okay. So now, so here, let's see. Yes, program is completed. Okay. Now do you have run jar? No, right? Okay. It means in the backend, what happened? So there's a program run jar started here. Run jar started here. Okay. So this is the run jar. So what run jar has done? Run jar has submitted the request to resource manager. Okay. So in this message, you can clearly see that okay, connecting to resource manager head h3n1.hadoop.com. Okay, 181 machine. Okay. So it connected to S3N1 machine and submitted whatever the command line has given. Ranger has submitted that command to RM. Okay. What immediately RM is doing? Okay. RM has given. Okay. So what RM is doing here? RM has given one number here. Okay. So it is accepting this job. Okay. And immediately it has given a job. Okay. A job ID. Okay, normally, okay, so it is a job ID, or you can call it like an application ID also. Okay, both are same. This is the number it has given. Okay, this is the number it has given. Okay, so immediately it has given. This is the number. After that, okay, who is the user who submitted this job? Who submitted this job? Alan. Yes or no? Okay, so it will type Alan here. Okay, what is the current status? Okay, submitted. Okay, okay, so initially the status will be like new job. Okay, new job. Okay, so now let us understand. Okay, let us understand what has happened. Normally, whenever there is a new job, what will happen? What RM will do? RM will see who is having more resources and try to launch application master. Correct or not? Okay, so now how to see that information? Okay, so guys, okay, so whatever the job you submitted, what is the job you submitted today? What is the job you submitted today? Application underscore 934 underscore 001. 934, this is the one, 934 underscore 001. Okay. So user is Alan. Okay, name of the job is word count, type of the job is map reduce. Okay, this is the table I'm showing you guys. Understand? This is the table. Okay. User name, type, okay, Q name. Okay. Then what is the start time? What is the launch time? What is the finish time? Okay. What is the status? What is the final status? Okay. So complete information you can see here. Can you see here, guys? Complete information you can see here. Okay. So this is the information which will be stored by resource manager. This is the information which will be stored by resource manager. Where? In the application state store file. Understood? So every job submitted to resource manager, okay, will have one unique job ID or application ID. Will have one unique job ID or application ID. Okay. Without job ID or application ID, you will never have any. You will never have any. What to say? What I can say? Any job running in Yarn actually. So this is must. Application ID is must. Okay. Now, okay, let us go and see the history of this one. Click on history. Okay, when you click on history, okay, so where application master started? Okay, here you can see application master. Okay, where application master started? Where it started? On which node? H3. Okay, So it means okay. It means okay. As soon as you submit the job, as soon as there is a job, immediately. So RM has allocated the job ID. After that, okay, it checked in the node manager information. Okay, who is having more resources? It understood that okay, S3 and 4 is having more resources, so it launched application master here. Okay, application master launched here. What is the size of application master it launched? How to check the size of the application master? Huh? You submitted a job. Okay, it is completed also. Now you want to see what is the size of application master you used in this job. Okay, so this is the file. Okay, so when you see here, okay, guys, okay, you should know how to navigate this UI, because this is the UI every day you will use. Okay, so here there's something called configuration. Click on configuration. Okay, when you click on configuration, so here, so these are the properties which you used. Total 1484 properties which you used in this program. But did you use what and all you used here, guys? You just told okay, what is this is what your command. Okay, you told what is my jar file, what is the class name, okay, what is my input file, and what is my output file. Only 4 parameters you passed. Yes or no? Yes or no, guys?
Yes, sir.
Okay, so you just passed 4 parameters, but okay, here Hadoop is saying that okay, I have okay 1484 parameters. Got it? Okay, and this is the file which will talk about. Okay, so which will talk about all the parameters, all the properties you okay RM used in this job execution. Okay, but here you can see okay each and every parameter. Okay, so here there is a parameter job.x. Okay, see here, this is the parameter and this is the value. Okay, this is the key and this is the value. And okay, this property from where it has taken, from where it has taken, huh? It has taken from core-default XML. It has taken from core-default XML. Okay, so there are some properties okay where okay, it has taken okay, see here from core-default it has taken 308 items. Okay, and core-site, from core site XML it has taken 5 properties. What are the properties that is taken? So what are my journal nodes? Okay, what is my cluster? Okay, what is the trash interval, checkpoint interval, trash interval, or topology? See, these are the properties it has taken from core site XML. It has taken these properties from SDFS site XML. It has taken 25 properties or parameters. Okay, so these are coming from SDFS site XML. Okay, so then okay, programmatically there is something called programmatically. Okay, let's see here programmatically. What is this programmatically? So programmatically, wherever you see properties like programmatically, okay, so those properties are mentioned. Those properties are mentioned in your job. Okay, are mentioned in your job. Okay, let us see what are the properties here. Okay, what is the name of the file? Okay, input file input format input directory. It means okay, what is the input file you have given? On which file you have run this program? Sample1.txt. Correct? Correct or not? Okay.
Yes, sir.
Yeah. So from which machine you submitted this job? From which machine? 186 machine. It means a edge node. Okay. Who is the user submitted this job? Okay. Let's show 100 entries here. Who is the user submitted this job? Alan is the one who Alan is the one who submitted this job. Okay. What is the output directory? The output has been saved. Is it the output directory? Huh?
Yes, sir.
Yes or no?
Yes,
Okay.
sir.
So these are okay. What is the name of the job? Okay. So word count is the name of the job. Okay. And okay, what is the okay. Okay. So here what else? Okay. So what is the how many mappers? Okay, it has taken 2 mappers. Okay. So how many reducers it has run? Number of reducers. Okay. So So here job.maps, job.reducers also you should have. Okay. So these are the ones, okay, these are the properties. Okay, so here, okay, this is the reducer class. Okay, this is the mapper class. Understood? Okay, this is the combiner class. Okay, so these are all the properties which has come from programmatically. Okay, it means, okay, from the jar file. Okay, so whatever the jar we used here, in this jar, okay, in this mapreduce.examples.jar, as I told you, you will have multiple classes. Yes or no? When I say a jar, okay, what are all different classes you will have?
Main class.
Okay. What are the different classes you will have? Okay, so where I mentioned that. Okay, so when I say a jar file, you will have main class, mapper class, reducer class, job configuration class. Okay, so all this information, okay, it is showing here. Okay, after that, okay, did we pass anything in the command line? So if you type command line, okay, command line, okay, nothing we passed. Did we pass anything in the command line? Nothing we passed. Yes or no? Okay, so it means no properties I passed, okay, in the command line. Okay, so this is the XML file. This is the XML file which talks about all the properties. You understood why this XML file is required? Huh? Sir, okay, there is a job. Okay, how do you know that? Okay, how do you know after, let it be, okay, during the execution time, or okay, let it be after completion of the job. Okay, if you want to know who submitted this job, okay, how do you check? From which machine this job got submitted? How do you check? What time it is submitted? How do you check? When it is started? When it is ended? So all the properties, okay. So then, okay, at this time, okay, what are the who is active named? What is the input file? What is the output directory? All this information will be maintained in the configuration file. Okay. So now, who is creating this configuration file? So here there is a configuration file for each job. Okay. So every time application master starts. Okay. So where application master has started here? Where application master has started here? Application master has started in this location. Okay. This is the location. Okay. Once it is started, okay, what RM will do? So whatever the job it received from Len, okay, it will hand over this job to application master. Understood? Whatever the job it received from application master, once it is updated here, then it will forward that job to application master. Okay. What application master will do? Application master will connect to name node and get the blocks information. Okay, name node told, okay, yes, okay, your file is sample.txt is having only 2 blocks. This is block 1 and this is block 2. Okay, so unfortunately, both the blocks are in same node. Okay, so after that, okay, what happened? What application master is doing? Okay, first, okay, whatever the properties it has received, okay, with all those properties, okay, it is creating one job conf XML. This is called as a job conf XML. So job underscore dot XML. This is the file which will be created by whom? Who will create this file?
Jar file.
Huh?
Jar file.
Application master. Okay. So, and where this file will be stored? This file will be stored in
Jar file.
STFS. Okay. This file will be stored in STFS. Which path? This is the path. Okay. Class TMP, Hadoop, can staging, history done. Okay. This is the location. Okay. If you go to this location, okay, you will have this file. So STFS, DFS, -ls. So do you have this file or not? Okay, so it is saying, okay, this guy is not having permission for this. Okay, who is STP? Super user STP user. Okay, so I will do one thing. Okay, so no problem. Okay, we'll see the same. Okay, if he is not having permissions, okay, so then okay, we will see with S3 and 1. Okay, can you see? Do you have this conf XML or not? Where is this one? Where is this conf XML? Is it in Hadoop location or not? This is on Hadoop location because okay, I'm using SDFS DFS. Okay, this is the Hadoop location. Again, okay, What is the replication factor for this file? Huh?
3.
The file replication factor equal to 3. Okay. And what is the size of this file? This is the size of the file. Okay. It means, okay, what application master is doing, as and when it receives the information from it receives the new job from application from resource manager, application master immediately creating one job conf XML with all the properties, okay, it is going to use in that job. Okay, this configuration XML will be very important for you, okay, for you to check, okay, what are the different properties you used in the program. Okay, what are the different properties used in the program? And again, okay, you can see what is mapper size. Okay. Map.memory -MB. Okay, so here, okay, you can see, okay, what is the memory. What is the mapper memory here? Huh?
1 GB.
Okay. So what is the size of
1
mapper
GB.
here? What is the size of
1 GB.
mapper?
1 GB.
1024 MB, 1 GB. What is the size of reducer? 1 GB. Yes or no? Understood?
Yes, sir.
Okay. And a application master. Okay, am.memory.mb. Okay. What is the size of application master?
204.
2048. It means 2 GB. Okay. So the size of a application master, okay, so here it has used the default one. Okay. So the size of the application master is, okay, 2, okay, 2, okay, and code also here. Okay. Okay. So this is okay. So how many vCPU cores it is using? How many cores it is using?
1 core.
1 core. Okay. And size is 2 GB. Okay. So here it means, okay, the size of application master is 1 core plus 2 GB RAM. Yes or no? 1 core plus 2 GB RAM. Okay. Now as and when it is created, okay, it created a job conf XML and stored into HDFS. Okay. What do you mean storing into HDFS? Storing into HDFS means storing in this location. Storing into this location.
Distributed location.
Okay, distributed file system again. Okay, so this file, the size of this file is, what is the size of this file? Okay, this is these many bytes. Again, okay, if you see, okay, this file is, okay, so this file comes like the one block. That one block is stored with replication factor 3. Understood? Understood, guys? Okay. So after that, okay, this is what done. Okay, then what it has done? Okay, it understood. Okay, so now, okay, what it requires? Okay, it want to process, or it has to process this block and this block. Correct or not? Okay. So here, let's see how many mappers it executed.
Sir, can you tell once more that how to navigate to this configuration once again from application?
Okay, so this is the home page of your resource manager. Okay.
Yes,
So
sir.
whenever you submit a job, okay, the job will give you one application ID. Okay, this is an application ID. Okay, you can click on this application ID. Okay, first thing, and you can click on history. Okay, this is the first thing. Otherwise,
Okay, sir.
you can directly go to the last line, okay, last but one column. Click on history here. Okay,
Okay, sir. Got it.
click on history here. Okay, automatically it will take you to the history screen. Okay, so here you will understand, okay, where application master is launched. Okay, it is launched on history and 4. And okay, if you want to see the job configuration, you can click on the configuration. Okay, so now, okay, so after seeing this configuration, now you can see, okay, map task. Okay, how many map tasks it executed? How many map tasks it executed? Huh?
2.
2 map
Two.
tasks. Okay, so this is task 1 and this is task 2. Okay, now, okay, what is the status of both the mappers? Succeeded. Okay. Now you click on first mapper. Okay. Where it is executed first mapper?
5.
H3
And
N5.
5.
It means okay. So mapper 1 executed on H3 N5. Okay. Why H3 N5? Because my block is here only. Sir, who is this, sir? Nandini M. Please be on mute. Okay. A lot of noise.
Sir, RM, how will understand 186 as a node that means edge node?
See, RM doesn't know whether it is edge node or any other node. Okay, so RM is capturing this is the from this machine the command has received. It received the command. Is RM telling that this is edge node?
No, no.
It is telling that okay, so from this machine 186 machine I received the. If you see the configuration here, okay, if you see the configuration here, what it is saying?
186 is
Submitted host address. That's it. It is not telling that it is edge node or any other node.
okay.
From
That
which machine?
receive that much command. Okay.
The request is received from this command, from this machine.
Okay, sir. Fine.
Okay.
Okay.
Request is received from this machine.
For our understanding purpose only, we it called as a
Edge node, but okay, this is our edge node.
okay.
Sir, how to check same information in the command line mode, CLM mode?
I'll explain this one. The same information, okay, if you want to see, you can see from command line also. Okay. But however, okay, you just cat this file. That also will give you the same information. Okay. Because if you want to check this in the command line, just okay. dfs-cat. Okay, configuration XML. This will print all the 1024 okay, 1400 properties here. You need to check in this. So if you use command line, okay, it will come like this. Okay, it is not so easy to read from command line. That is the reason. Okay, you will use UI to see all the properties.
But what if you don't have the UI access?
Resource manager UI access is must in any company, any cluster. Okay, without resource manager UI, users will understand what are the jobs they submitted. So admins will understand okay how to troubleshoot an issue in the job. UI is a mandatory one. Understood?
Okay.
And if you start resource manager service, okay, UI will start automatically, right?
Yes, sir.
Yes or no? You are not doing anything actually here. You are not doing anything special. Okay, you are just starting your resource manager. Did I start any UI separately? I started resource manager. Okay, I connected to resource manager. Okay, using the IP address. That's it. Got it. Okay.
Yes.
So,
Sir, one more thing, sir. Sir, earlier class you said that the resources will taken by the application master. It all depends upon the user, right? Whenever the job submitted.
Sir, whenever the job submitted, first okay, the request will go to RM. Okay. What RM will do? RM will provide a job ID and update this application state store. Once updated this information, immediately what RM will do? RM will check in this report who is having more free resources. Okay. In this scenario, it understood out of these three node managers, it understood that okay, this has more free resources. So that is the reason it informed okay, node manager to launch application master. Okay. So node manager 2 has launched application master with the size of 1 core and 2 GB.
So that's what, sir. How the application master know to take the 1 core and 2 GB RAM?
So that's the default property, sir. Okay, so here, okay, so if you see here, how this will understand. Okay, so let us see this one. Okay, resource.mb. Okay, from where it is coming, sir? Application master size 2 GB. Okay, from which file it is coming?
Yeah, okay, that configuration.
So it means okay, this property is coming from that configuration file.
So that is minimum. Oh, yes, that is okay. Okay.
Okay, this is coming from the configuration file. Okay, and which configuration file also it is mentioned here? Mapred-site XML. Clear?
So for
Okay.
for any job, it will take same configuration, sir. Same resources.
If you don't mention, okay, so if you okay.
So for every job, you cannot change the configuration, right?
I'll tell you, sir. Okay, so if you give me some time, okay, you will get complete clarity. Okay.
Okay.
Yeah, give me some time. You'll get complete clarity. Okay. So
Mhm.
now in this job, okay, when I executed this job, I didn't pass any parameters and all. Okay. I'm just given, okay, what is my logic file, what is my input file, and what is my output directory. This is what I've given. My job is executed with all default properties. All default properties are taken from these site XML, core site XML, HTTP site XML, okay, and YAN site XML, core default XML, HTTP default XML, okay, YAN default XML, okay. So these are the XML files, okay, it has taken. Understood? Okay, and it executed also. Okay. Whatever properties you mentioned the site XMLs, okay, the same size of application master will be taken here. The same size of mapper will be taken here. The same size of reducer will be taken here. Okay. So in the XML file, okay, I've given application master size is 1 core 2 GB, and okay, mapper size I've given as 1 core 1 GB. Understood? Mapper size I've given as 1 core 1 GB. 1 core 1 GB I've given. Okay, mapper size. Okay. So that is the reason. So on this machine, mapper one started with 1 core 1 GB. Then okay, so and okay, if you click on second mapper, it also started on S3 and 5. Okay, second mapper also started on S3 and 5. Why both the mappers are launched? Okay, in this machine only, guys. Normally, what is the logic here? Wherever data blocks are available, there the JVMs will be launched, containers will be launched. That is the rule, right? Yes or no? So now application master understood that okay, block one is here, block two is here. So application master is going to RM and asking, okay, hey RM, okay, yes, please be unmute, okay. Say, hey RM, okay, so my block one is available here, my block two is available here. Okay, can you give me 1 core 1 GB mapper one in this machine? And okay, one second mapper also in the same machine. This is what okay requested by application master. Understood? That is the reason okay it has given here. Okay. So if my blocks are available in different machine, okay, it may give a different machine, but here both the blocks are available here, so both mappers are started here only. Okay. So now, okay, what each mapper has done. Okay. Now what each mapper has done, okay, you can see task overview also you can see task overview. Okay, so this is executed on S3 and 5 machine. Okay, and okay, here you have information like okay, what time it is started, what time it is ended, how much time it has taken, complete information actually. Okay, for each task, okay, you can see okay, complete information. Okay, so then coming to the reducer. Okay, so once the mappers are completed, where they will store the map output, wherever it is running, in that machine, local file system, it will show the output. Yes or no? So mapper one is running here. Once it is done, okay, it will store the output in the local file system. Mapper two also running here. It will store the output in the local file system. Okay. After this, what will happen? After this, what will happen? Okay. So both the mappers will be released by application master. Okay. So application master will tell RM, okay, release this mapper one and mapper two. Okay. Immediately RM will inform node manager, hey, release mapper one, mapper two. Okay. So mapper one, mapper two are released. Mapper one, mapper two are released. Okay. At this stage, okay, sorry, at this stage, okay. So before this stage, okay, map M1 output, okay, M2 output, okay, are available here. Sir, no.
So both the mappers stored in the same node, sir. It's 3 and 5.
Sir, same node. Because okay, where blind, it's a blind rule that okay, wherever mapper one is running, the output of that mapper will be stored in that particular machine, OS disk.
The mapper 2 also the same.
Yes, of course. Okay, both the mappers are running. Okay, so both outputs will be stored in a separate directory, sir. Understood?
Okay.
Okay, so mapper one output okay will be stored where? Okay, so will be stored on which location if you want to see. Okay, so can you see this one? Where is the temporary directory? Where is the temporary directory? This is Hadoop temp directory. This is the temp directory.
So two mapper containers created in the same node here.
Yes. Okay, so okay, so if you want to see the intermediate output directory, okay, this is the location you can see. This is the location of where it will store the output rates. Understood? Okay. So this is the location where it will store the output. So here it will store the output like this. Okay. Hadoop temp directory. Okay. So let me show you what is this temp directory.
So this is local directory, yes?
Yes, sir. Yes, sir.
Yeah.
Okay. It's the location. But okay, what is Hadoop temp directory? We will see. What is Hadoop temp directory? Well, Hadoop temp directory is this is the location. This is the location. Okay. So what is the username here? Username is nothing but len. Okay. So it will store underscore slash temp slash Hadoop len. Okay. Under that one. Okay. So this is the one. Okay. Now we will go and see this location. This path is on this machine. Okay. This machine S3N5 machine. Okay. LL/temp. Okay. Do you have? Okay. Actually, you see, once the output is, it will be deleted, right? That is the reason you don't see here. Okay. Otherwise, you will see. Okay. Okay. Can you see this one, guys? This is the location. Okay. 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 So this started with okay. Right. Okay. So this is the location where your temporary output will be stored. Okay. Inside this one. Okay. So you have something called okay user cache. Okay. Under this one you have len. Okay. Under this one L cache. Okay. That it is removed. Okay. Cache is removed. Okay. So understood, guys. Here, this is the location. Okay. Under len. Okay. So you will have okay. You have application ID actually. Your application ID. After under that, okay, you will have your task ID. Under that, okay, your output will be stored. It means okay, inside this location itself, okay, mapper one will store output in one subdirectory. Mapper two will store output in the another subdirectory. Understood? Are any questions? Understood? Are any questions, guys? Okay. So this is the place okay, where it has written the mapper output under here. So now mapper one is released and mapper two also released. Okay. Mapper two are also released. Okay. So now what next? It requires reducer. Now it will go to reducer. Now if we click on reducer, how many reducers executed for this job? One reducer. Okay. And okay, if you want to see where it is executed, it executed on S3 and 3. It executed on S3 and 3 machine. Okay. This is the place where reducer one is executed. Okay. So now the question is that okay, see, my partial output one is here, mapper output one is here, mapper two output also here. But why reducer is here? Is there any logic for reducer? It should be launched in this machine only. There is no logic to launch reducer wherever you have free resources. Okay. Wherever you have free resources, okay, there you can.
Blanket for me, it gets launched in the same machine actually. So
that's what, sir. That's what. Okay, it depends. Okay, so at that time, okay, whichever machine is free, whichever machine is have more resources, okay, in that machine it will launch. Okay, so now reducer one is launched here. You know what is the size of reducer one? Okay, what is the size of reducer 1? Again, 1 core, 1 GB RAM. This is the default size of 1 core, 1 GB.
Sir, whichever machine is free means whichever node manager is free.
Exactly, sir.
Okay, okay.
Whichever node manager is having more resources. That's what my meaning. Maybe in this time, okay, there may be some delay in releasing the node manager. Okay, this mapper 1, mapper 2 here. That is the reason, okay, RM understood that, okay, reducer 1, okay, here, okay, this is having less resources, so let me give it here. Okay, so to launch reducer, there is no separate logic, guys. There is no separate logic. Understood? Okay, so now reducer is launched here. Reducer, what is the input for reducer? Mapper output 1, a mapper output 2. Okay, so here you can see the mapper output 1, mapper output 2 is the input. And now what is the output it will write? What is the output it will write? Okay, so you clearly told, okay, output should be written into which location? Output should be written into
Output location.
there is an output location, right, which you have given. Okay, so here this is the location of which you have given. This machine. Okay. This is the location we have given. Okay, so what it will do first, okay, reducer will take this to as input and quickly consolidate, and finally what it will do, it will ask name node. Hey, name node, I want to write, because okay, my requirement is to write this output on the store this output permanently on HDFS. My requirement is not to print on the screen. Understood? My requirement is to store the output on the in a file on HDFS permanently. Okay, so it is telling that, okay, I want to store my, it is going to name node and ask, hey, I have created some output, I want to store that output into HDFS. Okay, so again, okay, so now what will happen? HDFS will help reducer to write its file into name node will help, okay, reducer to write the file into HDFS. Now if we go to HDFS DFS-ls project BLR, okay, output location. So now you will see two files. One is underscore success file. Other one is part-r-000 file. Okay. So underscore success file is a file which will be created to tell you that, okay, the job is successfully completed. And okay, part-r file is your output, final output file. Okay. But did you tell the name of this file? You told only, okay, store into this directory, but you didn't tell, okay, what is the name of the output file and all. You told, okay, you store the output into this directory. Okay, and you stored the output into a directory with the file name which is called part-r-000. Understood? Now, okay, did you tell, okay, what is, see, whatever you store on HDFS, it will have replication factor, right? What is the replication factor of this file, output file? 3. Okay, output file is 3. Okay, now if I want to cat, okay, again, okay, hyphen cat. This is the one. Okay, and what is the size of this file? Okay, let us do one thing. Okay, the output, okay, SDFS FSC. Okay, hyphen files, hyphen blocks, hyphen files, hyphen blocks, hyphen rack, hyphen locations also you can give. So now, okay, so output file is stored. Okay, output file is okay. What is the size of output file? It's 27 bytes. It means how many blocks you will get? Only one block. Okay, this is the BLK. This is the BLK. Okay, so this is the BLK. Again, okay, where and it is stored. One copy is in 185, 184, 183. Okay, this is the output file block. This is the sample1.txt file block, and this is the output. Okay, output directory slash part-r. This is the file. This is the file, and okay, so here, okay, your output is stored, but okay, it is stored into one block, 527 bytes. But okay, so here replication equal to 1. Okay, So here output directory, you didn't tell how many copies you want. That is the reason by default he has taken 3 copies. Understood? Understood, guys? What is the replication factor for sample1.txt?
1.
So while storing, okay, I stored sample1.txt is like, okay, 1. Okay? Understood, or any questions?
Sir, the replication factor is applicable for both input and output files, sir, for
sir.
only
Sir, for any file you store in SDFS, replication factor will come into picture. Okay? For any file you write into SDFS, the replication factor will come into picture. Okay? But it is up to you. Up to you how many copies you want to maintain. So for sample1.txt, I clearly told, okay, I want only 1 copy. Okay. But output, did I tell, okay, how many copies I want? See, I want to run a program on this file, but okay, and that file, that program will generate an output in this directory. But did I tell what is the replication factor of that file? That file? No. Okay, that is the reason by default it used, okay, replication factor 3. Understood?
no, sir. Actually, so for every job you have to modify the replication factor, sir. So where did you mention that replication in configuration files only? We have mentioned the replication factor, right, sir?
Yes, sir. Okay, in configuration file in SDFS site XML, you mentioned like my replication factor equal to 3. Okay, so it is taking that 3 and it is creating. So it is putting this 5 blocks into 3 nodes.
But where we mentioned that input replication factors for input file.
Sorry, input file. Okay, while copying the file itself, okay, we mentioned in the command line. Understood? So I copied this.
Can you show that one, sir? Where we mentioned the replication factor while in command line?
We have not mentioned, that's why it is 3. Yes, sir.
Wait, looks like we missed the previous classes. That is the problem. Initially, when I start my Hadoop, okay, have you seen? Okay, I copied this file. Can you see this one? Okay. What is the replication factor I use, sir, here?
Once. Okay, sir.
Understood?
Yes, sir.
Okay, while copying this file into project BLR directory, okay, I use the replication factor 1. Okay, while writing sample1.txt, I clearly told what is my replication factor. But okay, while writing the output, did I tell what is my replication factor?
No, sir.
No, that is the reason it has taken default 1 of 3. Okay. Okay.
So, okay, mention up to maximum 3 only, because you mentioned the replication factor maximum in 3 in configuration file. You cannot mention replication factor as a 4.
Sir, wait, sir. Nandu, sir, please wait. Okay. Looks like you are a lot of confused. Okay. So, fine. I'll go to the next command. I'll show you. Okay. I'll go to the next command and I'll show you. Okay. Now, guys, okay. You understood. Okay. So now, finally, what it has done here? Okay. It has taken, my program has taken sample1.txt as input. Okay. Okay. And it has created my output in this directory. And that output is also on SDFS. Okay. And that SDFS file has the replication factor of 3. Okay. But okay, here in this example, I have not mentioned any of the things. Okay, I just gave, okay, what is my logic file? What is, okay, class name in that logic file? What is my input directory and what is my output directory? Okay, so this is what I have done here. Okay, but next time what I am doing, okay, clearly try to understand clearly. Okay, this time, okay, here I am passing what is my last, what is the jar file, what is the class name. After that, what I am doing, okay, so I'm giving some, okay, split parameters. You don't know what is split at this moment. Okay, leave it. Okay, but here what I'm passing here. What is the size of application master I'm passing here? Nandu sir, you answer me.
3 GB, sir.
3 GB I'm passing. Correct or no?
Yes,
Okay.
sir.
But okay, what is there? Okay, see now. Okay, so now we will talk about this one. Okay. In SPFS, sorry, in mapred-site XML. Okay, what is the size of application master? 1 core plus 2 GB RAM. Okay, correct or not? Correct or not, sir?
Yes, sir.
What size? This is the property, okay, we have in each and every node. Yes or no? This mapped site XML is available here, 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 in all the places. Okay, we have mapped site XML in all the places. Okay, this is the properties we have. Okay, but now if I don't mention anything, it'll go with these numbers. But now I know that, okay, this application master size is not sufficient to run my program. That is the reason I am customizing that property in the command line, saying that, okay, my application master size is 3 GB and number of cores for application master is 2. Okay, so in the command line, what I'm giving, what the application master size I'm giving, 3 GB,
2 cores, 3 GB.
okay. After that, okay, what I'm passing, okay, I'm passing like, okay, what is the size of mapper I'm passing here? 2 GB. Size of the mapper I'm passing is 2 GB. 2 GB. For mapper, how many cores I'm passing? 2 cores. GB 2 cores. Okay. For reducer size, I'm saying, okay, what is the reducer size? 3 cores, 4 GB RAM. 3 cores, 4 GB RAM. 3 cores, okay, 4 GB RAM. Okay. So default mappers. Mappers equal to 1. Default reducers also equal to default mappers equal to based on number of blocks.
Sir,
Okay.
sir, can we go through that command once again? How you are initializing?
Sir, I'm explaining, sir, still. Okay. So these are the default mappers. Okay. So we are going with the same default mapper here. But okay, number of reducers, what I'm giving, number of reducers I've given as 2. Okay. So 2 reducers. Okay. So I'm saying 2 reducers. Okay. After that, what I'm still saying, okay, what is my replication factor? Whenever you are storing output, okay, you store the replicate output in this replication factor. Okay. So replication equal to 2, I'm telling. Okay. Then what is the block size I'm saying? Is equal to 50 MB. Okay. Normally, okay, so site XMLs. So if you see site XMLs, so what is the replication factor normally?
3.
What is the block size for site XML? Normally, what is the default block size? 128 MB. Okay. So then, okay, so there are 2 more properties. Okay, queue name. empty here, but QName here I'm giving like default. You don't ask me what is QName handle. I'll explain later stages. Okay. Okay. Maps per 2. Okay, sir. Well, as per my site, XML files in each and every machine, these are the properties we have. Okay. Normally, if you don't give anything in the command line, it will take application size as this one, mapper size as this one, register as this one, number of mappers equal to number of blocks. Okay. Then okay, default reduces 1. Okay, replication factor 3, block size 128 MB, QName empty. Okay, speculative execution equal to true. Maps speculative execution true. Reduce speculative execution equal to true. Okay, so these are the properties which we have given in the site XMLs. It may be on-site XML, mapper site XML, or SDFS site XML, any site XML. Okay, but now to run my program, okay, I cannot go with these numbers actually. Okay, these numbers are not sufficient to run my program. That is the reason what I'm doing in the command line, I'm customizing here. Understood? Understood, guys?
Yes, sir.
In the command line, I'm customizing. Okay. So again, okay, what is the input file I'm passing here? Sample2.txt. Okay. Now, okay, we will see SDFS, DFS, okay, SDFS, FS.
Sir,
Okay.
so one question, sir.
1 second, sir. 1 second, sir.
Okay.
Hyphen files, hyphen blocks, hyphen locations. Okay. Okay, now, okay, hyphen racks also. So now, this is the sample2.txt file. This is the sample2.txt file. Okay, now, okay, this is the file, okay, I'm executing now. Okay. My input file is sample2.txt. Okay. Replication factor of this file is 2. Okay. How many blocks it has? It has okay, 3 blocks. Okay. This is block 27, 28, 29. These are the 3 blocks I have. Understood, sir? Okay. These are the 3 blocks. Where is 27 we have? Where is this 27, 84 and 83? Okay. So this one is available here. Okay. 1827 is available in 183, 184 machines. Okay. This one, okay. Second block 1828 is available in 185, 183. Okay. This one is available in 183, 185. Okay. Then third block 1829 is available in 184, 183. Okay. So this one is available in 1829 is available in this machine and this machine. Okay. This is how my blocks are available, sir. Because okay, my input file replication is 2. Okay. This is the first block, this is the second block, this is the third block. Understand? Understand? Or any questions? Okay. And okay, I am passing all the required properties. Okay. I am customizing myself. Okay. Because I don't want to go with the default values. If you don't want to go with the default values, you need to mention your required parameters or properties in the command line. Okay. So when you put okay these properties in the command line, these properties will work only for your job, not for others' jobs. Understand? See, these are the properties which are applicable for all. Okay, these are the common properties. Okay. For all users. Okay. So these are the common properties which I'm giving for all the users. Okay. But some users, they are saying that, hey, that common properties are not sufficient for us. I want to customize. You customize in your program. See now, this guy, Alan is customizing, okay, in his program. It means, okay, these properties will work only for this job. Understood? Not for all the jobs. Or not for okay, other users' jobs. Understood? Understood? Or any questions?
Sir, end of the day, the resources will taken from node manager only, right, sir?
End up
Even-
taken from there only, sir. Okay, but okay, I'm customizing or not?
Yes, sir. Yes, sir. Got it. Understand.
Okay, so it means if you customize, okay, these customized properties will work only for your job.
If you want, you can customize these are all
You
configured.
customize, okay, sir. Okay, how many properties we have in Hadoop? 100, 484 properties we have. Yes or no?
Yes, sir.
See here, okay. So if you see this file, how many properties we have here? Total 1484 properties we have in Hadoop. Okay. If you want to customize, or you customize all 1484 properties, who will say no? Got it?
Yes.
Okay. So, but I don't want to customize. Okay, I want to customize. Okay, let's say 10 properties or 10, 12 properties I want to customize. Okay. So those 12 properties I put in the command. Okay. And I'm pressing enter. So now any questions, sir? Tell me. Somebody is asking me questions. Again, the process is same. Okay. As soon as I submit, okay, in the backend, okay, it started Yanjar. JPS started Yanjar.
Sir, I have a question, sir.
Tell me.
Sir, like you are giving block size and replication factor. So those are in storage layer, right? I mean, if you
Yes,
are giving,
okay. Those are in
giving
storage.
command, then where it is being used in
Good question, sir.
producing output reducer, right? Right, sir? Where?
Of course, yes. Okay. So where reducer output is getting stored, sir?
Yeah, that's what, sir. My
Ah.
understanding was same. Like while
Writing the output,
storing-
final output, it will use these properties.
Okay, sir. And if we are not, if we are displaying the output, then it is not required, right, sir?
Yes, yes. If you are displaying the output, okay, it is not required. If you want to store the output into a directory into SDFS one directory, then it will use these properties. Okay. Let's see, job is completed or not. Job is completed, right?
Yes, sir.
Or no? Successfully completed. Okay. What is the job ID here? It connected to resource manager. Okay, the process is same. This is the job ID or application ID. This is the application ID. Okay. Submitted application. Okay, 002. Now you go to resource manager. Refresh. Now do you have the third entry? Huh? So if you have so many entries here, okay, you can search here also. Okay, you can just search using search box. You can search here. Okay, you can get your okay. Alan is the user, again the same one. Okay, now you click on history. When you click on history, so okay, this is a new job. Okay, even this new job will have a configuration file. Yes or no?
Yes, sir.
Every job will have one configuration file, guys. Okay, every job will have a new application master. First of all, okay, let us see where application master is launched for this job. The application master is launched.
CL5.
Application master is launched. Okay, application master is launched on this machine. Okay, and what is the size of application master you have given? Is it like okay? In the previous example, okay, application master was 142 GB RAM, correct? Correct or not?
Yes, sir.
Okay, but okay, now is it the same? What are the properties used?
2 core, 3 GB RAM.
2 core 3 GB. Okay, so it means okay now okay when RM is launching a job, okay, now RM will check these properties actually. What is the size of application master? Okay, Alan is asking for this job. For this job, okay, he is not asking you to go with default. He clearly mentioning that okay, I want this size of application master. Okay, then it will create that size of application master. 2 cores plus 3 GB. Understood? Understood or not, guys? Because okay, you are explicitly asking the size of application master. Okay, if you still have any doubt, what is the size of application master it used? Okay, click on configuration. Okay, click on resource dot. Okay, resource dot MBUC. What is the size of application master it has taken, sir? Huh? What is the size of application?
3 GB.
Resource dot okay CPU course. Okay. The CPU course it has taken?
2.
Okay. And okay, for this, okay, can you see this one? From where this property is passed?
From command line.
Command line.
Understood. Okay. Now, okay, You just check, okay, from command line. Okay. When you see from command line, so these are all the properties. Okay, 14 properties we passed in the command line. Understood? Understood, sir?
Yes,
So
sir.
it means in the XML, it is clearly maintaining that, okay, so from where this property has come, whether it is given in the command line or whether it is given, whether it is taken from the core site XML or HDFS site XML or yarn site XML or mapper site XML. Okay, every information is clearly maintained here. Correct or not? Did we pass the block size here? 50 MB. That's right. Okay. We passed in the command line. The 50 MB property has come from the command line. Okay. Application factor 2 we passed in the command line. Okay. It says minimum, maximum. Okay, we have passed in the command line only. Okay. Then okay, Q name default we passed in the command line. Okay. How many reducers we want? 2 reducers. Okay, we passed it here only. CPU cores. CPU RAM. Mapper cores and mapper RAM. Mapper cores equal to mapper cores 2 cores and okay 2 GB RAM. Okay, and reducer cores 3 cores. Okay, and 4 GB RAM. Understood? Okay, so everything okay is getting written here. So that okay, if somebody submit a job, okay, after submitting the job, okay, everything will be recorded. Okay, what you submitted, everything will be recorded in this XML file. You cannot modify this XML file. Understood? Understood or any questions?
Sir, one question, sir.
Tell me, sir.
Sir, can you please clarify that output file, sir? I'm still confused. So
Wait, sir. Wait, I didn't come to. Okay. So now let's go as per the part. Okay. So now where my application master is launched in this machine, in this program, or for this program, where application master is launched in S3 and 5. Okay. If you want to check where application master is launched, okay, just check here itself. Okay. So application master, okay, it launched in S3 and 5. Okay. So after that, okay, what is next here? Okay. Mapper task. You can map task. How many map tasks do we have? How many map tasks we have? 2 map tasks. Okay. 2 map tasks. Okay. Okay. Otherwise, what I will do? Okay, I will remove these properties. Then, okay. There are 2 because of these 2 properties. It is coming like 2 actually. I'll remove these 2 properties. Okay. Now I'm executing. This is the third application.
So what is this file input format split mini size?
Okay. The more application here. Just click back. Refresh. This is the new application you executed. Okay. For this new application, okay, application master started on H3 and 3 machine. Application master started on. There is no rule that okay, if you run the same program, is there a rule that okay, application master should be launched on the same machine? There is no rule at that time. At the time of execution, whatever the machine okay, RM feels is having more resources and okay, it is more free. It will launch the application master there. See the same input okay, say input okay, same program earlier application master was launched on a different machine. Now it is application master is launched on a different machine. Okay, so this is the machine where application master is launched. Okay, then if you click on map task, okay, how many mappers are there? Normally number of blocks equal to number of mappers, right? How many mappers we have? 1, 2, 3 mappers. Okay, click on first mapper. Where it is executed, first mapper should be executed on first block. Okay, okay, my first block is available in 2 places. Yes or no? Yes or no, sir?
Yes, sir.
Okay. My first block is available in 2 places. Okay. Okay. Now, out of these 2 places, okay, where it executed is 3 and 3. Okay, it means okay. So mapper 1, map 1 of okay. What is the size of map 1 here? Mapper size 2
2
cores,
cores.
2 cores plus 2 GB. Understood? Map 1 is launched here. Okay. Where is map 2 launched here? Mapper 2. It launched on. Again, this also launched on H3 and 3. Okay. Mapper 2 also. It means mapper 2. See, mapper 1. Okay. See, I can launch mapper 1 here and I can launch mapper 1 here also. Okay. But it launched here. Okay. I can launch mapper 2 here. Okay. I have to say 1828 blocks 2 times. Here and here. I can launch here or here also. But it launched here only. Okay. So then, where is mapper 3? Mapper 3 also launched here only. Okay. Why it is launched in the same machine, guys? Okay, why it is not launched in different machines? Huh? Maybe that time, okay, these two were may not be responding properly compared to this machine. Okay. So that's the reason. Last year. Okay. Now tell me, okay. Okay. I launched all these things. Okay. So now what next? What next? Now each mapper will run. Okay. So mapper 1, mapper 2, mapper 3, all mappers okay, will write their output into local file system. Local file system here. Okay. In this machine, local file system, they'll write. Okay. Now, okay, let's come back to reducer part. Reducer task. Okay. How many reducers I asked to run here? Number of reducers? 2 reducers. Okay. So that is the reason okay, it will run 2 reducers. Okay. This is the reducer 1. This is reducer 2. Where reducer 1 has run? Reducer 1 has run on H3 and 5. Okay. And what is the size of reducer 1? Reducer size 3 cores 4 GB RAM. Okay. So here reducer 1 has run. Okay. So it has run on 3 cores 4 GB RAM. It has taken here. Okay. That's taken here. Okay. Where reducer 2 has run again. Where reducer 2? Okay. Come back. Reducer 2, it has run on again H3 and 3. Okay. Reducer 1 is here. Reducer 2 also launched here. Okay. 3 cores 4 GB RAM. Okay. Now each reducer will process some amount of data. Okay. So now reducer 1 will store 1 output, and reducer 2 will store 1 output. Okay. So now end of the day, what is the output of reducer 1? Now you go and check in this directory. What is the directory here? This is the output directory. Okay. SDFS DFS-ls. Okay. How many output files we have, guys?
2 output files, sir.
2 output files. Okay. So 2 output files we have.
But
Okay.
sir,
This is
one question is like, see, let us suppose we asked to search Hadoop. Okay. So now there is a possibility that reducer 1 took mapper
only
1
one
and mapper, yeah.
sufficient. Only one reducer is sufficient. But okay, here okay, this is the program to do word count for all words.
But
Okay.
sir, even in 2 reducer case, there is a possibility of see. Let us suppose Hadoop 1 means Hadoop 4 Hadoops are coming in first file.
One second,
As,
sir.
yeah.
1 second. Okay. I'll explain that also. Okay. First, let me complete this one. Okay. So now, since I use 2 reducers, each reducer will write 1 output. Yes or no? Okay. So now, this is the reducer 1 output. This is the reducer 2 output. Okay. So now, what is the replication factor of this reducer 1 output? Huh? What is the replication factor of reducer 2 output?
2 only.
2. Understand? So reducer 1 output is also 2. Replication factor output. Okay. Now if I run fsck command, sdfs fsck. hyphen files, hyphen blocks. Okay. Now you see. Okay. How many blocks we have? This is the part R. This is the small file. Okay. It has only one block, but replication factor equal to 2. Okay. So if you want hyphen location, hyphen ranks. Okay, where are the ranks? Okay. It means okay, this has created reducer one output has been okay. So since you have given two reducers, output okay. This is part 0, replication factor equal to 2. Okay, so this is the block 1923. And where is this 1923? 1923 size is 263 bytes. 263 bytes. Okay. And where it is stored? It is stored in 183 machine, 185 machine. Okay. It means reducer one output is stored in the form of this block, 185 machine and 181 machine, 183 machine. Understood? So these two are the reducer one. Okay. I'm sorry, reducer one output is this one. So this is one copy in data node 1. Okay, other copy is data node 3. Okay.
But sir, what was input for this reducer one?
Okay, reducer 2. Okay, replication factor equal to 3. Okay, and what is the block number for reduce this one? Okay, so for this is the block number. This is the block number. Okay. What is the size of this one? Is equal to 264 bytes. Okay. Where it is available? Again, this is data node 4, data node 3, data node 4, data node 3. Okay, so this piece of data. So data node 3, one copy, data node 4, one copy. Okay, so reducer one output is stored in two places. I mean stored in one block. Okay, two pieces, and a reducer to output is stored in one block, and that with replication factor 2. You understood till now?
Yes, sir.
You understood, right? Okay. So now, okay, sir, Nandu sir, you understood now? Are you lost somewhere?
Yes, sir. Yes, sir.
Understood, right? Output is getting copied into 2. Okay, I mean, okay, with replication factor 2. Okay. So now the question here is that, okay, sir, okay, if I use single reducer, what is the size of output I got? Okay, let us do one thing. Okay, previously I used single reducer on the same file. I use single reducer. Yes or no? In this location. Okay, use single reducer. That is, there's only one reducer output is there. Okay, if on cat, when I cat this one, how many words I got? How many words I got, sir? How many words I got? Total.
36.
Huh? 36 words I got. Okay. So all 36 words are counted by how many reducer?
One
So
reducer.
one reducer. So now, what one reducer has done? First, it counted how many times A is there. Okay. Then it counted how many times amounts there, how many times and is there, how many times Apache is there. Like this, okay. One after other, it counted all these 36. Understood, sir? One after other, it counted all these 36 words. Okay. How many times each word is repeated. Okay. This is first scenario. Okay. Coming to the other scenario. Okay. We use two reducers. When you use two reducers, okay, what is the reducer one output? This is the Reducer 1 output. This is the reducer 2 output. What they have done here, guys? What they have done? When I have only one reducer, one reducer only taken everything and counted one after that. Yes or no? But now, I have two reducers. First reducer is counting these words. Second reducer is counting these words. Okay? Understand? First reducer is counting. Okay. But let's see, end of the day, what are the total words here? 20 plus 18. Total how much?
38.
Huh?
38.
38. Okay, but here, how many we have? 36. How come we get 2 extra? Okay, we will do one thing. Okay. We'll copy all these things. We'll copy it here. Yes, both are same files or are different files.
Sir, reduce one output, reduce two output there, sir. Above, sir, above, sir.
Hmm?
Above. Sir, come down, sir. Reduce one output, reduce.
Shit. Reduce the one output, reduce the see. These are the two extra things. Okay. Sorry, this is what I have used. Got it. Got it, sir. Huh?
So
Now you see,
output is same, yes, sir.
output is same. Okay. Sir, okay. I will give you a simple example, sir. Okay. You go to the fruits example here. You take this fruits example. Okay. This is the one. Okay. I've asked you to count only apples. I've asked you to count only apples. Then what you will do, sir? You will segregate only apples. Yes or no? Huh? When I count, okay, see, this is the my big box, okay, and this is divided to small boxes, okay, and this is my 20 tons fruits divided to small boxes, okay. I have asked you to count only apples. Then what will happen? Segregation will happen on apples. Segregation will happen on apples, okay. Consolidation also will happen on apples, okay. Finally, you are getting 2 lakh apples. Okay, it means okay, your output is only one item. Yes or no? Yes or no, sir?
Yes, sir.
Okay, but I asked you, okay, to count apples and bananas. What will happen now? Huh? If I give one consolidation person, what he will do, sir? What he will do? If I ask you to count apples and bananas, what you will
First
do?
he will count
See,
Apples
first,
and
okay, sir,
bananas.
segregation people, what they will do, they'll segregate, okay, from each box, they'll segregate apples and bananas separately. Yes or no? Like how you have apples, okay, they'll put bananas separately. Correct? Yes or no? Sir,
Yes, sir.
as per your requirement, they will do the segregation and they will do the consolidation. Okay. So now if you tell, okay, I want to count only apples, okay, then segregation people will bring only apples out of this box. Okay. But if you say I want apples and bananas, okay, they'll bring apples separately, they'll bring bananas separately. Correct or not? Correct or not?
Yes, sir.
Okay.
Yes, sir.
So what I will tell, I'll put some banana also here. And for us, bananas also, okay, what they will do? They will segregate like this actually. Okay. They'll segregate, okay, apples, bananas from this box. They'll segregate apple, bananas from this box. They'll segregate apple, bananas in this box. They'll segregate apple, bananas in this box. Or not. Okay. So now for consolidation, how many items I have? Huh?
Two items.
2 items. But earlier,
Only one item.
One
so
item.
when you have only 1 item, you cannot use 2 reducers, 2 consolidation people. Understand? But I have two items. I have 2 consolidation items. Then
Two reducer containers.
I will use 2 reducers. Okay. So I will use 2 consolidation people actually.
So one question here for two reducers,
So
Venkat.
one person will consolidate apples, one person will consolidate bananas. Okay.
So
We have a two mappers, two
input,
reducers
input.
required. Or not?
Sorry?
We have two mappers. We need two
Do we have
reducers.
2 mappers here? How many mappers we have here? How many boxes we have?
For
200.
mapper.
200 boxes.
Okay, yeah, 200.
For 200 boxes, okay. But okay, how many, sir? 200 boxes, okay, I have. So 200 segregation people I'm using. But okay, I have, okay, consolidation items are 2. Because okay, finally I want apple count and banana count. If I want apple count, how many items I want in the output? Only 1 item. Yes or no?
Yes.
But I want apple and banana. It means how many items I want in output?
2 items.
So, okay. So to fast my work, okay. See, suppose if I have only 1 person, how he will count this? Tell me. If I use only one person, so what he will do? Okay. First, okay. So he will say apple, banana. Okay. So let's start with A. Okay, apple. Okay. He'll go to all 200 outputs. Okay. He will take all apples. Okay. And he will say, okay, finally 2 lakh apples. Okay. After that, what he will do? He'll go to each 200 boxes. Okay. So he'll go to banana. He'll count, okay, each and every banana from the segregated output. And okay, he will say, I have 1 lakh bananas. Understood? Understood, sir. This is what, okay, 1 person. Okay. But okay, here 1 person is doing 2 things. Calculating 2 items. In this scenario, can I use 2 people to calculate, to consolidate? If I use 2 people, then what will happen?
One will count apple and another
One will count apple, one other one will count bananas.
Banana.
Parallelly work will go. Correct or not? Huh? Yes or no?
Yes, sir. Yes.
So like this, okay. So like this, okay. If you see the sample1.txt, okay. So if you see, okay, this is the one. Okay. Sample2.txt, okay. Sample2.txt. It has okay, 6 unique words. 6 unique words. Okay. So now, if I use single reducer, what will happen? What is single reducer? Tell me. Single reducer, okay? So one reducer, okay, reducer 1 will count all 36 words. All 36. That sir, each word is one fruit, sir. If you have two fruits, okay, so one after other, okay, the same person is doing consolidation. Yes or no? But in the frame, okay, in the place of two fruits, okay, I have 36 fruits now. Okay, so every fruit will be counted by same person. Yes or no? But I want to reduce this time. Okay, so what I can do, okay, what in case if I use two reducers, maybe reducer 1 will count, okay, 18 words. Reducers 2 will count, okay, 18 words. Yes or no? But okay, so whatever word counted by reducer 1 is the same word counted by reducer 2.
That's what my doubt, sir. How we will,
No, here okay, you see, okay.
how we will configure one reducer will count these words.
That I will explain. Who will take what word, okay, will be separate story. Okay. But tell me, see, the A word is completely counted by reducer 1 only. Okay. Is there any A in this list?
No, sir.
Amounts word is completely calculated by this reducer. Okay. Is there any amount word here? It means, okay, so here what okay, both reducers are doing, they are sharing the work here. Understood?
In this scenario, can we take 3 reducers, sir?
So which scenario I can take multiple reducers? Okay, so if you feel that, okay, your output is having more than one item. Understand? Understand?
Yes, sir.
Okay. Suppose, okay, so here, okay, now you have 36 unique words. Okay. If you use 3 reducers, what will happen? If you use 3 reducers, what will happen?
12 words.
It takes less time. It will count.
Yes. To count, okay, one person counting 36 words, it is taking 36 minutes. I'm just giving example. Okay. Two people counting parallelly, okay, 18 minutes only. Yes or no? Both will do parallelly, right?
Yes, sir.
18 minutes, okay. In this scenario?
12 minutes. 12 minutes.
Understood. I still want to reduce the time. Okay. Use 36 reducers. What will happen?
1 minute.
1 minute.
Okay. Reducer 1 will count, okay, 1 word. Reducer 2 will count second word. Like this, okay. Within 1 minute, it will be complete. Okay. I will give you some examples, sir. Okay. Now I want to find, okay, sum of, okay, I have employee table. My requirement is this one, okay. Sum of salaries, okay, for all employees. How many reducers we can take in this list? This.
So depending upon the number of employees.
You need to understand what is the output item.
One reducer is enough.
Different multiple numbers or only one number output?
We don't.
One.
Okay, one. Sum of salary.
Only one output. Yes or no?
Okay.
One output means, okay, one reducer. Yes or no? Okay. Even though you take second reducer will not do anything. It will sit ideally. Understood? Because we're expecting only one output here. Okay. But now sum of salaries for, okay, IT and HR employees. Separately. Okay. Now how many items I'm expecting?
2 reducers.
Huh? How many items I'm expecting?
2 items.
2 items.
Yeah. So here you go with the 2 reducers. Okay. But okay. Okay. Again, there is a thumb rule also, guys. There is a thumb rule also. Okay. If I go with 2 reducers, it means that 2 JVMs I'm using. Yes or no? Yes or no, sir? Okay. for a program to count, okay, see, now end of the day, okay, if you use one reducer, it is taking, okay, in 0.5 second to count this one. If I use two reducers, it will take 0.25 seconds. Yes or no? How much time you are saving, sir? Simple programs, right? Yes or no? Sir, okay, you take this scenario. Okay. How much time a reducer one has taken? You see here, this is the correct time. Okay, this is the correct time. Okay. How much time, when it is started?
268.
Okay. So, okay, let's say, okay, how much time reducer one has taken?
3 seconds.
Reducer to
4 seconds.
4 seconds. Okay. So it means, okay, when it is started, 8:13 it started. Both are started at 8:13, 8:13. Okay. Reducer one started at 8:13. Okay. This also started at 8:13. It ended at 8:16. Yes or no? This ended at 8:17. Okay. So tell me, this is 3 seconds, 4 seconds. Okay. Now total time, how much you have spent on this program? How much time you spent on the consolidation part? 7 seconds or 4 seconds? Huh?
7.
Sir, explain me one more time.
4 seconds.
4 seconds.
4 seconds, sir.
Parallel work is done. No?
Parallel.
Parallel work is done, right? Okay. So this also started by 8:13. This also started by 8:13. Okay. So now you see the start time and you see the end time. Okay. End time is 17, start time is 13. It means parallelly it worked. Okay. So 4 seconds. It means, okay. So my consolidation work is completed in 4 seconds. Yes or no? Sir. Okay.
Yes, sir.
Yes, sir.
I will give you one simple scenario, sir. Okay. Normally, what is the thumb rule for a worker, sir? So some cement worker, okay. So construction worker will be there, right? How do you pay? How much you pay per day? You will pay, okay, let's say 600 rupees you will pay per day. Yes or no? Okay. So what time to what time this guy will work?
Morning 9 to
Depends on the work.
Sir, Vinod, sir, you are the best person. Tell me.
morning 9 to 6, sir.
9 to 6 they are working, huh?
No.
Huh?
Otherwise, 10 to 2 and 3 to
Normally 9 o'clock they'll come. Okay, 9 to
Yes,
4 p.m. Okay, they'll wind up.
Yes, sir. Exactly.
Okay. So 9 a.m. they'll come and 4 p.m. they'll. Okay, good. Okay. But during this time, will they do only one work or okay, they'll do multiple works also?
Multiple.
Maybe, okay, see, okay, they came at 9 a.m. 9 a.m. to 12 p.m. Okay. Okay, they worked on, okay, all the bricks actually. Okay. They transferred, okay, bricks from one place to other place. Okay. So from 12 p.m. to 12 p.m. to, okay, 4 p.m. they worked on sand.
Yes.
Yes or no?
Yes, sir.
Yes or no? Okay. It means, okay, you have enough work. Okay. So it means, okay, the blind rule here is that, okay, you're calling a worker means. You're calling a worker means. Okay. So it is understood that, okay, this guy will work for at least, okay, 7 to 8 hours minimum. Okay. You take 5 only. Okay. 9 to 5. Okay. So the idea here is that, okay, this guy should work for 8 hours. Okay. But now, okay, if I call this guy, he is doing two things here. Yes or no?
Yes, sir.
He's doing bricks work and he's doing sand work also. Okay. But 9 to 12 is doing bricks work. Okay. Maybe, okay, 12 to 5 is doing sand work. Correct or not? Okay.
Yes.
But in this scenario, what will happen if okay, so since I have two works, can I call two workers? If I call two workers, okay, then okay, 9 to worker 1 will start at 9 to 12 p.m. Okay, he will complete the bricks work. Yes or no? So same worker 2 will complete by 1 p.m. Okay, he will do the sand work parallelly. Both will do parallelly and they will complete by 1 p.m. Okay. So here, okay, person one, you will have to pay 600 rupees. For person two, you will have to pay 600 rupees. Okay? But in this scenario, okay, you are giving only 600 rupees. Which one is best utilization, sir? Best utilization of resources.
For time saving, we can choose for second.
Always time is important or money also important? Huh?
Sir, both are important.
Sorry, understood. So here, okay, you are taking only one worker and you are giving enough work of 8 hours. Okay, so you are spending only 600 rupees. Okay, but here you are taking two workers. Okay, you are okay. The work is getting completed in 4 hours, but you are paying 1200. Okay, tomorrow, okay, let us take this scenario. Okay, so this worker one will come and he will work on, okay, an item, sir. To work on, okay, bricks, sand, cement. Okay, understand? Each item will you bring one person? Huh? Sir, okay, one person will bring bricks. Okay, one person will bring sand. One person will bring iron. Okay, one person will bring cement. Okay, one person will bring, okay, wood. Will you call 10 people now in that day?
No, sir.
No,
But
sir.
everybody is having only half an hour work.
Yeah. After that, they will sit ideally.
If you use, okay, 10 people, okay, first of all, okay, your cost is increasing, 6,000 rupees you need to pay. Okay, but okay, all 10 people will come by 9 o'clock. Okay, they'll start at 9 o'clock. They'll complete their work, okay, by 9:30. After 9:30, they are sitting ideally. Even though they sit ideally, you have to pay money. Yes or no?
Yes, sir.
In this scenario, going with one worker is better. One worker, okay, doing slowly is better. Or, okay, bringing more workers, okay, giving, okay, completing the work in half an hour and making them ideally and paying them is better.
One person is better.
Huh?
One person is better.
One person is better, okay. So because, okay, if I have 10 items to transfer, okay, I cannot bring 10 people, right? See, because when I'm bringing 10 people, I should show enough work also. See, when I'm taking, what is effective utilization of resources? Resources. Okay. What is it? Okay, effective utilization of resources means if you call a worker, you should give 8 hours work. That is the effective utilization of work. Okay, you are calling a worker, but you are giving only half an hour work. Okay, your money is waste.
Yes, sir.
Correct or not?
Yes.
Huh?
Yes, sir. Yes.
Yeah. Okay. So here also, since I have two items, doesn't mean that I'll go with two reducers. When I feel that, okay, if I go with one reducer, it is taking too much time for me, then only I will think about 2 second reducers. Understand? If I know that, okay, these two things, okay, I need to transfer bricks and sand, okay, this will take, okay, 20 hours, okay, this will take, okay, 15 hours. That time I will go with, okay, 2 people. Yes or no? But if I know that, okay, this both work will go for 8 hours, I'll go with one person only. Sir, your resource is very important. Resource is costly right here.
Yes, sir.
You have to pay. Okay. Even in real time also. Okay. So whatever the containers you launch, for each container they will charge you. How the charging and all will work will be applicable. I'll talk about that later. But in real time, if you take a container, they will charge you for that container. Okay. So I'm taking a container. It means, okay, at least, okay, see, my container lifetime is container lifetime. Okay. So if it is a mapper container, okay, it should, okay, if we have work for 1 to 2 minutes, then it is a good container. This is the thumb rule. Okay, normally for a worker, okay, what is the thumb rule of good worker? It should work for 8 hours. Yes or no? This is the good utilization. Okay, effective utilization of resource here. Okay, but okay, if I bring, okay, 2 workers, worker 1, worker 2, okay, worker 2. This guy, okay, you are giving worker 1 only 2 hours work. You are giving 2 workers, okay, 3 hours work. Okay. Rest of the 6 hours, this guy will sit ideally. Okay. Rest of 5 hours, this guy will sit ideally. So this is ineffective utilization of resources. Ineffective. Understood? Okay. So what is effective mapper runtime? Effective mapper runtime is 1 to 2 minutes. Okay. Effective reducer runtime is, okay, so 5 to 10 minutes. Okay. Now you take this one. Okay. Here okay, I've taken 2 reducers. First reducer is running for 3 seconds. Second reducer is for running for 4 seconds. Do I really need, okay, 2 reducers here? Tell me. See, if I use single reducer, if the single reducer is taking more than 5 minutes, then I can think of second reducer. Okay. See, even if I use single reducer also, hardly it will take 7 seconds. Yes or no?
Yes, sir.
Both work done by single reducer, 7 seconds it will take. Correct or not?
Yes.
Okay. In that scenario, why I want 2 people? You got my point? Hmm? It's a waste of reducers, right? So it is like, okay, so you are bringing 1 reducer, okay? But what is the thumb rule for a good reducer? It should work for 5 minutes. If your reducer is taking more than 5 minutes, think about second reducer. You know, in real time, normally what they will do, they will run a job first. Okay? They'll run a job with 1 reducer. Okay. If this 1 reducer is taking, okay, this is a thumb rule, guys. Okay, this is not okay definite rule where you can apply everywhere. Okay. So they'll run the job with 1 reducer. Okay, let's say it is taking, okay, 20 minutes. Okay. Now what they will do? They'll run the same job, okay, 4 reducers. This is the utilization of resources. Why 4?
5 minutes.
Within 5 minutes, the job will come.
Exactly. Exactly. Understood. And at the same time, okay, you should understand, okay, a few things, guys. Okay, what is my output here? How many items I am expecting in the output? Okay, see, if you are expecting 36 words, okay, in your output, okay, you can go with 4 people. Okay, 36 means, okay, 4 nines. Okay, each reducer will count. Okay, okay, but okay, I'm running a job. Okay, I have only 1 word to count. Counting that 1 word is taking 20 minutes. Okay, even you use second reducer also, then you use.
Other reducer will be waste. It will be just
Even though you start, okay, 1 work will be done by 1 reducer only. All apples will be counted by 1 reducer only. Okay. So even if you put second reducer doesn't have any other code to count. It will sit ideally. First reducer only will count for 20 minutes and give you the output. Understood? Consolidation work, okay, will not be shared by 2 people. If apples are there, all apples should be consolidated by single person. If okay, bananas are there, all bananas should be consolidated by single person. But okay, in the segregation work, okay, yes, okay, we have sharing work. Understood? See here, okay, in the segregation place, okay, see here, maybe here somebody is doing apples, okay, so here this box is counted by 1 person, 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 okay, in the segregation part, okay, and the segregation. So in this box, okay, apples are segregated by 1 person. In this box, apples are separated by second person. In this box, apples are separated by 3rd person. In this box, apples are separated by 200th person. It means, okay, all apple segregations are done by 200 people here. Will you agree with me? So here in Hadoop, there is a rule. segregation can be done by multiple people, multiple containers. Containers. Okay. On same item. Okay. But when it comes to consolidation, consolidation should be done by single container only. Okay, so what is the correct word? Okay, segregation. Okay, so one item can be segregated by one item can be segregated by multiple people. Okay. One item can be consolidated by one and only one
person.
Understood? Apple segregation is done by 200 people here, but Apple consolidation is done by
One person.
one person. Okay. Banana segregation is done by 200 people, but banana consolidation is done by
One person.
one person.
Means second
Okay.
person.
Yes.
Can't we use 2 persons at a time for segregation only? One person.
You are using right here.
That means you are telling that
Sir, I
200
have
people
200
per Apple. Then
sir, I have 200 boxes, sir. Okay.
yes, sir.
I have given 200 segregation people. Okay.
Yes, sir.
So one person is doing, okay. So this, each person on this box, each person, okay, working on one box. Okay. See, and again, okay, on one box, okay, you cannot give two people. One box cannot be given to two people for segregation. Understood?
Okay.
But one item in the box can be segregated by multiple people. The overall box should be segregated by, complete box should be segregated by one person. Okay. But inside box, you can have multiple items. Yes or no?
Yes, sir.
Yes or no? Okay. So if you have multiple items, okay, multiple item segregation will be done one after other by same person.
Okay.
Got it? Okay. But one box, okay, two people cannot do apple segregation and banana segregation. So here, okay, one box, the rules, okay, here in Hadoop, okay, one box, one segregation.
That means one item.
Okay, one box means, okay, may contain
Multiple.
one or more items. Understood?
Yes, sir.
One box. Okay, so one box is nothing but a block. On one block, okay, only one person should work. Understood? Sir, processing layer is not so easy to understand. You should put your 100% efforts, then only you will understand.
Sir, in this word count scenario, so how it will divide, sir? Words, two containers.
Okay, so okay, I will talk about that, okay, maybe in the evening class, sir, because okay, see, this is the flow. This is the flow. Okay, there is something called partitioner who decide, okay, so when I have multiple words and multiple reducers, okay, which one should be given to which reducer, that will be checked, validated by, that will be confirmed by partitioner. Understood?
Okay, sir.
Got it?
Sir, one doubt, sir.
Yes, sir.
Sir, this processing layer is in which Hadoop? Hadoop 2 or?
In Hadoop 2x and 3x. In Hadoop 1x processing layer is different.
Okay. So
Okay.
these are in Hadoop 2x,
2x, yes.
2 and 3x. Okay.
Yes. Okay, so guys, okay, we'll stop it here. We'll continue in the evening. Okay, so as I told you, we have class in the evening at 6 o'clock today. Okay, what I will do, I'll share this video with you, the video recording.
6 o'clock, yes, sir.
Okay, in the group. Okay, please go through it once.
Sir, 6 o'clock only class, yes, today?
Yes, 6 o'clock we have class today.
Okay, sir, thank you.
Thank you, guys.